let us see how to solve Cauchy-Euler equation. So here I am taking this example. We can identify a differential equation as Cauchy-Euler, Euler-Cauchy, if the coefficient of second derivative is x square and the coefficient of first derivative is x. Similarly, if we have a third derivative, then its coefficient must be x cube. Okay, so then we call that equation as Euler-Cauchy equation. So now the solving technique for this is we need to take x equal to e power z. So it means this imply what would be z equal to ln x. Okay, and we already know that capital D represents derivative with respect to x, and similarly you know d square and all. So now with respect to z, we will introduce new operator that we call it as theta. This represents derivative with respect to z. Now if you put this x equal to e power z and find the derivatives, finally this is what you are going to find. X dy, that becomes theta y, and x square d square y becomes theta into theta minus 1 into y. So now you can substitute back everything in the equation. Okay, let me rewrite this equation. So this one can be written in operator form like x square d square y plus 5x dy plus 4y equals x into ln x. By substituting everything in the equation, so this x square d square y becomes theta into theta minus 1 y plus, and this is 5 theta y plus 4y, which equals, and you have to be careful here, x, it means you need to substitute e power z, and ln x means z. Okay, so in place of x we will substitute e power z and ln x is z. So now let's simplify this one. We can take y out, and theta square minus theta plus 5 theta plus 4, this of y equal to z into e power z. Now if you simplify this is theta square plus 4 theta plus 4 of y equal to z e power z. Right. So now it's a differential equation with constant coefficients. So let's try to solve this. So we have, so initially what do? We will write the auxiliary equation. So that is r square plus 4r plus 4 equals 0, and of course this one can be written as r plus 2 whole square equals 0. Okay, it means the roots are r equal to -2 and -2. So it has repeated roots, and the complementary function is going to be c1 into e power minus 2. We should write z here. Why? Because this is with constant coefficients in terms of z, not in terms of x. Okay, plus this is c2, now z into e power minus 2z. And again we need to convert this in terms of x. Therefore the complementary function is c1 into this e power e power minus 2z. I can write it like this: e power z whole power minus 2. So e power z means that is x, right? So this is x to the power of minus 2 plus c2 into, you know what is z? Z is nothing but ln x, and again this becomes x to the power of minus 2. So simply we can write it like this. Therefore the complementary function is 1 by x square, which is common in both. So c1 plus c2 into ln x. Okay, so now we can actually see that this 1 by x square comma ln x by x square, these are solutions of homogeneous equation, right? What is that homogeneous equation? That homogeneous equation is this: x square d square y plus what's given, so 5xy prime. Okay, so that is 5xy prime or 5x dy plus 4y equal to 0. Okay, so these two are solutions of this homogeneous equation. Okay, next we are done with the complementary function. Now we need to find the particular integral. Alright, so let me go for finding particular integral. So here yp would be, so yp equals to 1 over this theta square plus 4 theta plus 4. I am directly writing like this: theta plus 2 whole square, and this acting on z into e power z. Okay, and you know that this e power z can be taken out. So once if you take e power z taken out, then this theta must be replaced with theta plus 1, and inside there is plus 2, so this whole square of this acting on z, right? And this equal to e power z into, it's 1 over, you know, theta plus 3 whole square, so it becomes, yeah, theta plus 3 whole square acting on z. So we can simply take the expansion of e power, 1 by theta plus 3 whole square. So for that you can do one thing. First, e power z over, you take 3 out, so that 9 will come out, and this becomes 1 plus theta by 3 whole square, whole power minus 2 acting on z. Okay, so we need to recall the formula for 1 plus x whole power minus 2 formula, right? I hope you know the formula for 1 by 1 plus x. That is actually 1 minus x plus x square minus x cube and all. Now let me differentiate on both sides. So if I differentiate on both sides, this side I'll get 1 by 1 plus x whole square, and that equals 0 minus 1 plus 2x minus 3x square plus 4x cube minus and so on. And you multiply with minus on both sides, so that finally the expansion for 1 by 1 plus x whole square, so the expansion is going to be 1 minus 2x plus 3x square minus 4x cube minus and so on, plus and so on. So this is how it goes, the expansion. So now using this expansion formula, I hope this one can be easily written: e power z by 9, and the expansion is going to be 1 minus 2 times of theta by 3, that's it, plus, I hope we don't need the rest. Why? Because we have z here, its second derivative is 0, so whether you write the next term or not, it doesn't matter. Okay, I'll keep and so on, and this acting on z. Okay, so now let me move upside. So this equals, what happens, e power z by 9, and this is z minus derivative of z is 1, so this is 2 by 3. Okay, and we need to convert in terms of x, but e power z is x, so x by 9, and z is ln x, therefore ln x minus 2 by 3. So this is the particular integral, that's it. Okay, and you got the complementary function and you got the particular integral. I hope finally you can write the general solution, so just by combining these two. Okay, so what is the general solution finally? So the general solution is y equals 1 over x square times c1 plus c2 into ln x plus particular integral, that is x by 9 into, I hope, what do you have there, ln x minus 2 by 3. That's it. Okay, I hope you understand, right?